So before we get started, I do want to give a notice. I'm going to be talking about tools, frameworks that developers have built an entire identity around. They have very strong feelings about these tools. Some people even have full companies that are using that tool, and they have a financial interest to see that tool succeed. I am not going to be attacking any of these tools. I'm not going to be attacking you, your personality, anything that you choose to use. I just want to talk about these tools and how they work, how they compare towards one another, and what really sets them all apart. So we're going to be talking about cross-platform. I've been in this space for roughly closing in on 10 years, which is a really long time. And I feel like that gives me some bit of authority to talk about the different tools that exist these days. Considering I've come from the days where there was maybe one or two, and they weren't really that good. We're going to take a look at some of the more modern ones that are light years ahead of what came around during the 2010s. I work for a company called Ionic, Director of Developer Relations. Not that that means anything, but I do a lot of work in this space specifically. So let's start off by just defining what cross-platform development is in a nutshell. Basically, when we talk about cross-platform development, we are saying I have a code base written in any language, and I'm going to be utilizing a tool that'll let me take that program and deploy it to various targets or devices or environments where it maybe isn't the quote-unquote native language for that system. This is something that exists in the mobile web landscape. It's kind of not the norm to a certain degree, but there's an environment where this kind of philosophy is common practice. Has anyone played Elden Ring? Any video games? Yeah, someone's very excited about Elden Ring. I am excited for that as well. Video game development is totally driven by cross-platform practices. There's rarely a chance where you're seeing somebody release a platform exclusive these days. It doesn't really make sense if you're only going to target one market. But you have tools that exist that allow you to take your idea, build it in one kind of abstraction, and then you're able to deploy it to Xbox, PlayStation, Steam, Nintendo Switch even. And chances are you've heard of these tools as well. Anyone have heard of Unreal Engine? Some people are very excited about that. There's also Unity. Some people are very excited about Unity. Does anyone know what that third one on the right is? So it's called Solar 2D. It originally was called Corona SDK. Name change was a very good choice here. But all these tools exist to be able to let developers work in some sort of abstracted environment, and they can deploy whatever they write to these various platforms. For example, Solar, you write in Lua, and then you deploy to iOS and Android. Totally cool. Now, the web ecosystem has this as well, where we have various tools that exist using different approaches to allow you to write an app in one language, subset of languages, and be able to deploy it to various devices. So you have your React natives, Ionic, and then this other one called Flutter, which is kind of the new kid on the block. And I don't know about you, but oftentimes I look at articles and people try to pit all of these tools against one another. There's always going to be a React Native versus Flutter, Ionic versus Flutter, Flutter versus everybody else. It's kind of not a good way to look at this, because when you try to put everything up against one another, you're not going to get a fair comparison. Because I said, people might have identities that are built around a particular topic. They might be working for a company that is invested in it, which is around this time, I should say that I have a bias. I work at Ionic. I want to see Ionic succeed. My livelihood depends on Ionic being successful and people using it. But I also have to know React Native or Flutter to be able to speak about it somewhat intelligently. So as I go throughout this, please keep in mind, I am biased because I like a particular tool, but I hope that my comparison is not going to be so negatively impacted by that. So if we think about comparing all of these different tools and how they work and what the day-to-day expectation is going to be, we need to rethink how we do comparisons. Because most of the time, people are going to look at comparisons as being, oh, X is better than Y because reasons. Most of the time, it happens to come down to performance is the best reason why to pick this tool, when performance is not necessarily something that is a result of the tool that you use, but more the code you put into that tool. You could write really crappy code and get a slow app with any of these approaches. You can write really fast code in really great apps using any of these solutions. So we're not going to look so much at performance because, like I said, it's not really a good metric to compare. We're going to look at what aspects do these tools concern themselves with. We're going to look at every aspect of the development lifecycle and kind of see, okay, what did I need to adjust? What did I need to know? Did my choices impact any aspect of my development? And I've broken it down to these 8 key points. So not extensive list. You probably have other things that you're more concerned with. But I broke down project setup, language choice, the ability to debug it, which I feel like is super important. But a whole bunch of other things as well. And these features, I think, really capture the difference between all of the solutions out here. I built the same app 3 times to get a good idea, and I have all of the code up on GitHub already. I was a very good presenter who committed his code early. Take a photo of this. If you don't get it, the links will be available at the end, and I will share my slides throughout the app. But you're going to see the same example, and we're going to look at some of the code, time permitting, to get a good idea of where each of these tools kind of shine, and what are some things that you need to know before getting into them. So we're going to start with probably the most common thing, or the most common tool that everyone knows, thanks to Facebook's nearly infinite marketing budget. We're going to talk about React Native. Kind of riding the coattails of React's success. What they did was say, hey, we've figured out how to abstract the browser environment and the DOM, and they said, why don't we just do this for native? It's a really great idea. It actually is a really good idea. So instead of you having to write the controls for iOS and Android, you just write a view or a button or a text. And that can get translated to the appropriate controls for iOS and Android on the fly. Behind the scenes, how it actually works is really cool. They have an embedded JavaScript VM that will live inside of a host app. As your JavaScript is executed, it's making calls to a low-level system provider to say, hey, this person wants a button. Go render a button, however you need to do that. Which I think is really fun because people like to think that it compiles away to a fully native app. There's still a JavaScript in there. It's still running inside of a VM. Nothing gets compiled away. So to get started with React Native, I first needed to pick which flavor of React Native I want to go down. Did I want to do the core React Native experience with no helpers, no utilities, or did I want to use something like Expo, which is a third-party company and tool that sits on top of React Native and provides a lot of nice extra features that makes the development experience much better. I kind of sat around, didn't really do anything with this, so I just said, to hell with it, let's just go ahead and use Expo. Expo is going to influence a lot of your decisions while you are building with React Native. I don't think that's an opinion. I think that's pretty clearly a fact, but if at any point you feel like it's too restrictive, you can eject out of it. So project setup, I run npx create expo app, and then boom, I have a nice little app over here. I get this really nice terminal UI, which as a person who lives inside of a terminal, good terminal UI is hard to come by. And then you have a kind of a blank component that gets rendered out, and then you can load it up on the simulator and you're off to the races. You can build anything out from there. So moving on to the next aspect of like, what does React Native do, or has it concern itself with? Language choice. So Expo and React Native, the core React Native experience gave me JavaScript by default. I'm a TypeScript fan, and I will die on that hill. TypeScript is the best. Thankfully, Expo had my back here. If I just added a empty TS config to my project, Expo recognized that and was like, hey, we should install TypeScript for you because you look like you want to use TypeScript. And it does that. It'll prompt you, go ahead and install it, rename all your files to .tsx, and start adding type information. Fantastic. Great to know that the tool's got my back. Routing. Here's where we get to our first kind of split. Did you pick Expo? If so, you're going to use this React Navigation /native package and a bunch of subsequent other packages that get installed behind the scenes. So this is kind of where React Native, I feel like, can be a bit misleading, because you can install one package, but congratulations, you now have 4 other sub-packages that are also installed, and now you have to maintain those packages in the versions. If any of them introduce a breaking change, yikes, not great. If you didn't pick Expo, you have more options. You could use this React Native navigation, and trying to say both React Native navigation and then React Navigation /native is a bit of a tongue twister. So I'm very proud of myself that I did that in the first try without messing up. But the reason why these 2 packages are your choices is because Expo will go ahead and link native packages behind the scenes for you. So if you are using a package that includes some native dependencies, you're going to hope that it is part of Expo's blessed package ecosystem, because it'll say, hey, you're reaching for this package. I know it needs these dependencies. I will go ahead and just automatically set that up for you, which is good until it's not. Third-party libraries. Again, this kind of builds on top of the routing example. If you pick some of these packages, you're going to hope that it does have Expo support or Expo supports that package. Otherwise, you're going to be managing native dependencies yourself, which if you've never done that before, it is not the most fun use of time. There's other things that you could be doing, like actually building your app. But you are going to be searching for kind of React-specific tools or React Native-specific tools and libraries that are not going to be the same as the ones that you would use on the browser. So for instance, I like this package called Quill.js. It's a rich text editor, super fun. I could not use that in React Native without going through some hurdles. I had to go find some random package on NPM, hope that it was maintained and that it was supported in this version of React Native, and then NPM install, hope everything's gonna work well. It ended up working really well, but I had to relearn something new that I wasn't necessarily prepared to do or expecting. So in addition to this, there are going to be some platform-specific packages, and it kind of gets back to a central idea behind React Native is that you don't write once, run anywhere. You learn once and write for anywhere, where they expect you to have some platform-specific code as part of their core identity, because they realize that some of these platforms are going to be so different and require so many different expectations. They should, just support that and let people do that. So third-party libraries, kind of, hope for the best, expect the worst. Make sure that you have good version control and good version control practices. And then anytime you install anything, if it just yells at you, nope out, and basically reset. Native API access, again, did you pick Expo? Because Expo provides a lot of good utilities on top of React Native core. So for example, in the demo, we have a file system API that we are bringing in from Expo. Gives you a nice kind of node-like file system API, but still is not core to React Native experience. And there's other libraries that are like this. While React Native core does provide some of these features, you're most likely going to be looking for something from the third-party ecosystem, which could lead into, okay, now I need to hope that this person is maintaining this package. Otherwise, congratulations, you now need to write Swift, Objective-C, Java, Kotlin. And as someone who has never written Kotlin or Java, oh, that sure is, that's something I don't want to do. I know, I said it at a Vox event. Java's not my favorite language. I'd rather write Swift, but still, I now have to learn a new tool, a new ecosystem that I wasn't expecting to do. Not really my favorite thing. I will point out, this is not unique to React Native. I will let you all know that. This is going to be a common theme. Web deployment. Has anyone ever looked at the Twitter web app? Looked at the DOM, inspected the element tree? No one. That's only me? Okay, yeah, I am the nerd that will do that. If you've ever looked at Twitter, the element tree or the source code for that, it is a React Native web app, or React Native web app. It uses this library that lets you translate the React Native components to the equivalent DOM components. There's two libraries in here. Again, Expo is going to influence which one you pick. There's React Native Web, React Native DOM. Both of them feel like an afterthought. Like they saw all the goodness that they were getting with React Native iOS, React Native Android. They want to bring the web into the mix, and it's not as smooth of an experience as they like to promise. And the generated DOM that you get out of that is something. If you ever want to look at deeply nested divs and try to do the performance analysis on why that's a bad idea, go look at Twitter. Sorry, Twitter. Tooling and debugging. That web deployment was kind of a downer. Tooling and debugging with React Native is actually really good. Something I was very impressed with. If you have this whole kind of cross-compilation, cross-platform, there are two separate kind of silos where you're going to be spending your time debugging. Some of it is in the native landscape, but that rarely happens, actually, unless you are developing those plugins and packages. Most of the time, you're going to be focused on your app components, your React-specific code. And with that, they have this really nice system where you can proxy all of that through a web worker to your browser dev tools. So if you're using Expo, you can open up a localhost URL, and it'll pump all the information to a web worker, and then you can start setting breakpoints inside of your components, inspect the local state, use things like React Dev Tools, which will let you inspect the components itself, and even this really nifty on-device element inspector. So if you're starting to style your components, change the layout, and you're like, why is my button not doing what I expected it to? You can open up the inspector and just kind of inspect that element live on your device. It's actually a really, really cool thing. UI design features, I'm not going to spend too much time on this because I didn't really style my app. I just used whatever the provided components were. Inline styles, I will say, can get you super far, but if you want to work with designers or work with somebody who maybe just knows vanilla CSS, there is a style sheet function which can give you an object like CSS. You're going to notice it's a little different. It's probably better to reach for this thing called React Native Elements. They provide this theme function which you can basically extend pure components from their package system. Think Emotion, Glamorous, where you can extend built-ins. And then obviously there's some helper functions in there to help you mimic what would be styled on the web to the native equivalent. And I guess we can kind of take a look at how this works. I was going to just do it at the end, but YOLO. So here is our React Native app here on the right side of the screen. We can go ahead and say add a note, and we're going to say live from the stage. And then let's make that bold. No, bold, add some emphasis there. And then we're going to save. I can come back here later on, edit this, do whatever I want. If I want to delete it, and if the simulator wants to behave, the joys of running beta software, you could swipe to delete it and then have that list, that item be removed and the file deleted. So this is all tied up using the file system API from Expo, all using third-party components from React Native Elements, using React Navigation/Native, good on me, using that stack navigation controls and using their whole paradigm for routing around. I'm not going to get into the code because, again, time constraints, but you can check it out on GitHub and see how the whole entire app is built. I'm not going to give any kind of, evaluation of how I think React Native did until we get to the end. Next one. So Ionic is one, obviously, that I have the most experience with and the one that I am the most, biased towards. But we're going to try to not let that color this evaluation. So Ionic exists as a two-part kind of tool. There are the core UI components, which are available for Angular, React, Vue, or no framework at all, if that's how you want to operate. And then there is a native portion that essentially gives you an enhanced web view, which can render your entire web app, and then it will proxy communications between the JavaScript that you write and then the native system underneath. At its core, it ships as web components, which maybe no one really cares about web components. Web components, yay? Okay, some people thought it was yay. It's not really something that you need to worry yourself about. It's more just a design decision that we've made and influences how you actually approach the styling, which is going to be really interesting. So to get started with it, we do install a global CLI. Then you can say Ionic start. You'll be prompted to give it a name. And then you can pick a framework, pick your adventure, and then you are prompted to also pick a template. So there's things like a tabs-based navigation, a single route, kind of like the Expo one, and then a side menu layouts for the people who still like the side menu UI, which is me. That's the one I often pick. But from here, once we're done, we have an app that is loaded up. I picked Angular for my framework of choice because I felt this was already too React heavy. And I have an app that is up and running. We have a nice little UI and design, basically an empty route that we can use throughout our app. We also have a live reload server, so as this is running on the simulator, I can make my changes and have it update onto the simulator basically instantly. Okay, so now for the evaluations phase of everything here. Language. We default to TypeScript for everything. You might not think that's a good decision. And if so, you probably use Vue or React, which is a little bit slower to adopt TypeScript. Angular fans like myself, we've had TypeScript from day one, and that's something that we're going to be using. For the Vue and React folks who are still dead set on sticking with JavaScript, it's pretty easy to nope out of it. You just change all the files extensions and remove your TS config, and then you're good from there. But you're really kind of missing the point if you don't use TypeScript. I think so. Routing, we delegate this to the framework itself. For instance, we just build on top of Angular's router, React's router, and Vue router, but we add some really nice things in there as well. So we built on top of it to give it this native-like navigation where you can have multiple navigation stacks that are independent from one another. So if you think of Twitter as the native app, you could go to somebody's tweet, go to their profile, go to another tweet, and have this deeply nested navigation stack, and you're only on the home tab. You could go to search for that person, then go to that tweet again, then go to somebody in mentions, and then follow that account. All of those navigation stacks are going to be separate from one another and can be maintained across the entire life of the application. We also provide the animations and transitions by default, so you don't ever have to wire that up, because if you've ever done router animations, it is not fun. We've done all that work for you. Third-party libraries. Have you ever heard of this thing called NPM? You could literally pull any package from NPM, whether it's just as long as it's working for the browser. Don't try to pull in a bunch of node libraries. I've seen people do it. But any JavaScript or TypeScript package you can install and be happy with. Only caveat is that not every library out there is built for mobile. They are very desktop heavy. And so you could pick a package like let's say chart.js, which works great on the desktop. But if you try to put that on a mobile device, the performance may be great. You probably want to use something like C3 instead. So there's plenty of opportunities to pick the wrong libraries and shoot yourself in the foot. Native API access. Again, this is provided by that second part of Ionic called capacitor. That said, it is an enhanced web view. It gives you the native runtime and then a collection of APIs that you install separately to be able to access things like file system, geolocation, Bluetooth. But what's really nice here is that the APIs that you are provided are platform agnostic. So if you want to say call the file system, you're calling Capacitor's file system API, and behind the scenes, it knows I'm on iOS, use this file system approach. If I'm on Android, use that. And if I'm on the web, use this. And if that feature doesn't exist, we can fall back to something completely different. So there's a lot of flexibility in here to be able to work with APIs that maybe don't exist in the browser yet. And if they don't exist at all, we can just gracefully fail and reject a promise. And then that's up to you to figure out how to work around that situation. Maybe you are that person that throws up a banner that says, hey, this would be better in the app than it would be on the web. Don't be that person, but you could do that. There's an extensive core set of features that we provide as well as a community, but if none of those features provide exactly what you want, congratulations, you now need to go write Swift, Kotlin, Java. You need to maintain a plugin for this. Much like React Native, it's not something that I want to do, and I'm sure most web developers don't want to learn this ecosystem as well. So each one of them has a downside here when it comes to trying to extend the platform and include functionality that doesn't exist yet. Again, let's go on a high note. Web deployment. You are working with HTML, CSS, and JavaScript at the end of the day. Web deployment is a no-brainer. Netlify, Vercel, Firebase hosting, even your own FTP that you are pushing everything up on there, all that can work. And like I said, the native features can gracefully fail. So even if you are on some old version of Safari, because let's face it, it's most likely going to be Safari where things fail, you are going to be able to handle that pretty gracefully. And if there's features that you want to hide or you want to change the layout, we do provide some components, but media queries and good old CSS are going to be your best friend here. Tooling and debugging, browser dev tools for the win. You're going to be able to open up Chrome, Safari, Firefox, and just have those dev tools right there with you. If there are framework-specific dev tools like Angular, React, and Vue, those tools are also going to be available to you. So your known environment for debugging and inspecting your app is going to be basically what you do for the web these days. What does become really fun is when you deploy to a device remotely, now it's connected via USB, you can remote debug and inspect everything while it's running on your phone. So if you're on Android, you would just go to Chrome://inspect. And if you're on iOS, you just go to Safari's develop menu, and then you should be able to see that target as an inspectable target, which is really cool. So now you can have most of your development time spent on the device and have those dev tools working with you. And then again, live reload. What a great, good feature to have on there. UI and design features. I am going to spend a little bit of time on this because this is probably the thing that sets Ionic apart from all the other tools, and that is its use of web components and CSS variables. CSS variables, if you've never used them, think of them like Sass variables, but built into the browser and not compile time information. It's all runtime. So if you're inside of an app, you could basically have that app be themed one way. Maybe do a class or some media query for like dark mode. You could just change those variables and the entire UI would update automatically. It also has this really good feature of being able to scope specific variables to an individual component. So if you want to modify the button padding, it's easy to just say select a button, modify the padding, and that's propagated throughout your entire app. You could scope it to an individual component or subcomponent on a specific route. You have a lot of control over how this works. Modern CSS has gotten really, really good You can use things like the has selector as well and be able to have more fine-grained control over how your app looks and how it updates depending on various component state. Really, really awesome stuff. Before we get to Flutter, let's go back to our demo. And here we have the Ionic app. And again, we have the UI. We have this nice kind of collapsing header that's just built right in. We can go to this note. We can say it's note 1. It is no longer note 1. We're note 2. Let's go ahead, add a item 5, and then we're just going to save. We can go back to that note, see all the changes propagated. Same behavior that we saw in the React Native one. Instead of having the swipe buttons, just because I wanted to mix it up, let's say we want to delete this note. Congratulations, the note has been deleted. All those file system operations are happening within the web app and are calling the native functionality under the hood. So really, really great. Ooh, my battery is at 25%. We are just gonna hope that this lasts. Flutter. Again, the new kid on the block, something that everybody has asked about. It's like, Flutter, it's going to kill everything, right? Not necessarily. There are some good reasons for this. I will speed through it just to make sure I leave room for questions. It is an open source approach for cross-platform from Google, which has an excellent track history of not killing products. RIP Stadia. It is written in Dart. And it uses a custom renderer for all of its controls. So you're not actually rendering a native control, you're actually rendering something to what is essentially Canvas. Different opinions. You can deploy it to iOS, Android, and web, and a bunch of other platforms as well, which is really, really interesting, but also a benefit of how they approach their rendering system. I wouldn't call it much of a cross-platform framework. I would call it a cross-platform rendering engine, because that's really what it's doing under the hood. But to get started, brew, install Flutter, use whatever appropriate package manager that you have. But once you have that Flutter executable, you can just say Flutter create my app, and then boom, you have your app running on an iOS simulator. What's really nice is that out of the box, they give you a stateful component, which is just a component that can have some state, great naming. And then you can click this button and have that be incremented. And you can see how the interactions between what you do in the app and how the state gets updated. You can see how that works. Dart. It is indeed a language. I actually didn't hate it, which is really, really, I had this expectation it was going to be a terrible time, but it turns out Dart is actually pretty cool. It was familiar enough for me as a JavaScript developer that I felt comfortable after maybe 5 minutes. If you have a Java background, you probably are going to even feel more comfortable. There were some things that I had to wrap my mind around, like what is this app override thing? Had no idea what that was about. But thankfully, they have a really good tooling and editor support story. So as I am someone who works in Vim, I was able to get up all the Flutter dev tools and all of the language server stuff for Dart that I could just autocomplete my way to glory, and my app was working. Routing, it follows this more native-like approach to handling route changes, where instead of having definitive URLs, you are pushing just components onto this global stack. So this is actually pretty similar to how React Native works as well. You have this push-pop kind of navigation approach, and all of your components just get added to that, and then they can be removed. Third-party libraries are all provided by this pub.dev, which is their equivalent of NPM. Things like SQLite, HTTP, Firebase, geolocation, what have you. What's pretty interesting is that you see a lot of first third-party packages, which is where all the packages may be maintained by the Flutter core team. They are not part of core. So even though they are third-party packages, they're maintained by the folks that write the system. Feels weird that you don't have that just baked in. Then again, Capacitor also does that same kind of approach where we have all the plugins scoped as separate packages. Part of your native API access is driven by this as well. So you are installing packages from pub.dev for things like geolocation, file system API. But if there is something that you want to do that isn't available to through those third-party packages, congrats, you're writing a native plugin or a package as they call it, which could be writing Swift, Java, Kotlin, or C++. I would assume that you're all comfortable writing C++. No one did a gasp or anything? Again, that's a common trend throughout all these tools, is that once you start to need to write something custom or native, it's good to know that you have somebody who could write those and has the experience of writing that code. Otherwise, you're going to kind of feel alone or isolated. Web deployment, Flutter does have the ability to deploy to the web. I would argue probably don't do that because the payload size for what you ship to the user is massive. They have this two options. One is kind of Flutter Lite, which has limited functionality and sometimes not as great support for third-party packages. And then they have Flutter, the full kitchen sink and everything else, where all the rendering is done through this package called Canvas Kit, which is run inside of WebAssembly. Nested dolls of technologies at this point. It's a lot of things that you are going to be checking out. Third-party packages that you pick are also going to influence your web deployment strategy. You might not want to use Flutter for the web if you realize, hey, your rich text editor isn't going to be working. And surprise, the generated DOM is all canvas, which raises a bunch of other questions around accessibility, which we should all be striving to make sure our web apps are accessible to a certain degree. With this, they'd have to re-implement basic things like tab navigation or voiceover support. Let's bring it back up again because the web deployment story is a bit of a downer. You do have the ability to have a really good debugging experience. If there was an error while I was developing my app, the dev tools were really good at saying, hey, here's where the error is, here's what the error actually is, and here's how you can fix it. Which most of the time I was missing a semicolon, which I just felt very targeted for that because of all the years of not writing semicolons in JavaScript. But once you have that system set up, you could just go ahead and write your code and know that it was going to be somewhat safe. When you do need to inspect the DOM, they have a really good DevTools story. Instead of having an elements panel, they have what they call a widget tree. But then there's also memory monitoring, network monitoring, where you can inspect the entirety of your app and kind of understand how are we going through performance and how are we going with why is this HTTP request taking so long? You can kind of monitor all that stuff in a familiar environment. And just so that way I can close out the entirety of everything, here is not the Flutter app. Here is the Flutter app. What we have going on is our editor. We can say, yes, I was testing. I can come over here. Testing works. We'll save. Automatically updated. We can hit new to open up a new tab. And we could also delete them. If I recall, what did I do? I don't think I built the delete functionality in this. But the delete functionality would also be pretty similar to just adding a button here at the top and then calling the native functionality for this. Now, I showed the demo before this last slide for a very particular reason. If you notice, that app was using a very material design look and feel. And as an iOS person, that really just broke my heart. Flutter, obviously being from Google, has an inclination to point you towards material design first, which might be a good decision, might not be. You then have to go ahead and figure out how does my app react to an iOS situation. You have to conditionally change the theming for that on your own. Not terrible, you can do it. There's really good stories and documentation on the site about how to do that. I just wish it was provided by default. Theming capabilities are also pretty awesome. You could go ahead and rechange the entire UI to feel like your own custom brand, but it does get tricky because certain colors are not available in the iOS story, and then they are available in the Android. It just becomes kind of complicated. And then this is all dependent on Flutter's runtime because, like I said, they are a rendering engine first. So if they change how that is going to work, you now need to update your app to account for that. it is what it is, I guess. So again, link for all the source code, because we're not going to have time to look at all of that. Take a picture of it or wait for the slides to be shared. I do want to close out with like, what is the point? The point is that all these tools have different pros and cons, and it's all going to depend on what your team's makeup is, what your skill level is, and what you are comfortable with. The one thing to keep in mind, performance is never going to be the issue if you're writing optimized code and being smart about how you do this. The space doesn't need to be zero-sum. These other tools don't need to die for one to be successful. They can all exist and collaborate with one another to improve the development experience, but also improve their own performance. And in the end, as a maintainer, I win because I learned something new, but also as users, you all win because each tool is driving the competition. So I'm already at my time, I believe. Cool. Thank you so much. It's been super awesome to be here. Hope you enjoy the rest of the conference.